with almost no limitations. So we can call this also as a real wireless world. It has an incredible transmission speed, and also we know that it can be used for high data capabilities, and also it possesses several advantages and also disadvantages, and more power features. If we take a large phone memory, if we want to have a more dialing speed, more clarity in the audio and video, we are going to prefer particularly 5G communications. So as we all know, our evolution of this wireless communication has started from basic from 1G to 5G. So 1G was developed in 1980s and its speed was up to only 2.4 kbps. Next came 2G. So it was the speed was up to 64 kbps, and we can use the services like digital voice and SMS with some more clarity. So the 2G handsets are developed and they came on with 2.5G. Then in late 1990s, what happened to present day, the transmission speed has been increased from 125 kbps to Mbps, and we can possess super voice quality and a good clarity in the video conference calls. All this can be done through 3G. Next, coming to the particular era which we can know is 4G. As we know, it has developed in the year 2010, faster and more reliable, and speed performance is up to 100 Mbps. Easy roaming we have, and also low cost. That is why nowadays everyone is going for 4G. So coming to our webinar topic, that is the present research is carried out on this, and several patents have been published and several conferences have been conducted on this, is the major phase of the mobile telephone wireless system. 10 times more capacity as compared to 4G, and also the expected speed is above up to 1 giga. So we can say this is the next major phase of the mobile telephone wireless system. So although particularly on 5G, the evolution has started from 2014 onwards, as the bandwidth is greater than 1 Gbps, and we can have a dynamic service and the multiplexing technique which is involved in 5G, 4G or 3G, as we know that it is a CDMA technique. So the switching is also for all the packet. So coming to particularly the applications, why we go for this 5G is it can be helpful or use advantages in providing quality of services and also high resolution. These are the basic features, less traffic, connectivity and all. Coming to globally, it can be accessible and dynamic information access. So if we go for the applications of 5G, we can use it with wearable devices with artificial intelligence capabilities, media independent handover, VoIP, that is voice over IP enabled services, and also with 6 sense technology. So these are the basic applications of 5G. So coming to let us move to the slides. The new coming 5G technology is available in all the markets at affordable rates, high peak future, and also with the presiding technologies. That is why we generally go for 5G. So let me share the presentation slides for you. So hope the screen is visible to everyone. So let us go to our concept called as 5G communications. So as we are able to see the different pictures in the view, how we are able to use the 5G. So with robotics and also on the artificial intelligence as discussed on voice over the VoIP. So the transition to 5G. So this transition to 5G particularly we have a simple basic view of hyper connected vision, where we are going to cover all the 2G, 3G, 4G, 5, Wi-Fi and all. So specifically, the 5G is valid for specific data rates and also low latency. So if we particularly see these definitions, the hyperconnected vision of all the existing technologies are covered also with respect to 5G. So how this particular 5G is used in our present technologies related to 5G, and also how we are going to evaluate this particular 5G in all our present applications. Let us see the transition. So if we go back to that, we have particularly evaluation of air interfaces technologies. So you can see there are different standards, 5G standardization, what are its requirements, and what are the different wireless local area network standards we use from 1919 to 2013, which has a vast difference of frequencies, and also the long-term evaluation which we are using it for on this particular evolution of air interface technology. So the 5G standardizations are important where we have particularly higher data rates, efficient spectrum, spatial resource. Okay, so all these particularly important in enabling this high connection density. So particularly these reliable services can be provided by using this 5G standardization. If we take
Ma'am, your voice is not audible.
methods and also new frequency bands. So let us see what is the 3GPP standardization timeline. So if we take this 3GPP standardization timeline, we are so particularly these are used for 5G research prototype and also 5G product and 5G deployment. So the different phases are there from 2010 to 2021, where the first release of 5G for the specification has been carried out, and after the specification has been released in the year 2018, the second phase where we are going to analyze this 5G with respect to our third generation partnership project, which provides a mobile standard and gives us the different products and also deployments. Okay, so these can be involved with respect to the release from different 3GP standardization timelines. So these after particularly 2019 onwards, the LTE advanced phase C. So you can see from the graphical representations, the standardization timeline. Still progress of these has been carried out from the year 2021, and also research is being done to develop the 5G standard, 5G product, 5G deployment, and also trial and error method. But market has not still admitted the 5G SIMs. It is in progress. So max of 3 to 4 months, we may expect 5G communication, which can be helpful for all the applications as discussed. Next, what is why we are going to this drive the 5G? So if there's an explosive demand for wireless broadband, and also as we know nowadays the emerging technologies like IoT, artificial intelligence, everything they are able to communicate over the internet. So where we require a large number of smart devices, so there we are able to drive this particular 5G as an application. Is my voice audible to everyone?
Yes, ma'am.
Thank you. So these are the expected applications, or how we achieve this particularly. That is extreme broadband speed, ultra low latency, and also ultra reliable web connectivity. So these are the main objectives we achieve while we get particularly 5G. So ultra low latency. So this ultra low latency, so as we know, that particular extreme broadband speed, ultra low latency, where you want to have a high volume of data packets, and also while you send these data packets, even if the delay or any rapid changes to access the data is achieved, then a computer network should be stable to achieve this ultra low latency. So next, as we came, we need to have a set of network where we should be able to have a ultra reliable web connectivity. So these are the preliminary major objectives of 5G and also expected applications. Next, coming to how the 5G is driving into the present scenario, we will see. So these are the particularly key usage scenarios to drive 5G: user experience data rate, the next area traffic capacity, next ultra reliable and low latency communications, massive mission type communication, area traffic capacity, network energy efficiency. So these all scenarios are equally important while we go for the drive of this particular 5G. So user experience data rate. If the data rate compared to 4G, which is usable with the so for that, we should be able to check whatever the peak data rates we are able to access with respect to each and every user. So these are the EMB, enhanced mobile broadband, massive mission type communications, and also we are able to use it for a particularly in the industries, we are going to use massive mission type communications, and in where low latency and ultra reliable vehicle to infrastructure or for any autonomous driving, we are going to use URL So these are the key usage drives for 5G. And we have discussed how we are trying 5G, how it is related to present application. Next, how we are using it for the high videos, and also now in games also virtual and augmented reality is implemented. There also you can use this for enhanced mobile broadband, where we can achieve fast capacity and also ultra fast mobile communications. So all these are important in different applications where our 5G can be used for number of applications. So these can be enhanced to achieve some necessary transmissions from 4G to 5G. That is why we are going for this 5G communications nowadays. And a lot of progress of research is going on this 5G. A lot of people are applying projects on different financial educational institutions where they are able to do some research on this 5G and comparing it with the present communication generations and deploying some advantages and using some software tools, implementing it. So all these are carried out on the present research. So we can even apply a basic projects on where we can guide the students in our graduation level or on the post-graduation level, and do some innovative projects and build some projects for them. So the key 5G parameters which we can see is one is latency, peak throughput, area capacity, and all. the ranges are being mentioned here. These different parameters have to be taken into consideration while we are having some particular design parameters of 5G. So we have to uh, have the peak throughput and per connection, and also provide the energy efficiency. So all this then next, what are the 5G requirements? Summary, we'll see. So it supports new cases, it supports fixed mobile and wireless satellite technologies, and also large number of devices it connects, and it has increased bandwidth efficiency, and it can support from a low rate of to high bit multimedia applications. And we have a power backup by using this 5G. So these all are different requirements, and how it can be usable to an industry, any networks, or it can also be used to our wireless can be applicable to satellite access, or it can where we can use it for radar. All these are the general requirements how we can enable this particular 5G. So coming to practically, the users are using in the next era of emerging experiences and hyper connectivity. Hope you are able to see 3D UHD ultra high tele presence. Next, we can use it in tactile internet with human in book. So that also is possible through this ultra high. So these all standards are recommended by ITU, International Telecommunications Union, and in demanding conditions Next, how we can connect this particular 5G to the massive IoTs, Internet of Things, optimizing to connect anything, anywhere with efficient, low-cost communications. In smart cities, it is possible, and smart homes, utility metering, wearable fitnesses, remote sensors, object tracking, where power efficient, multi-year battery lifetime, and where the long range, that is we can track it, and also we can provide a or connect anything, and also particularly have a long range deep coverage, so in the smart homes. So all these are the different optimizations where we can use our 5Gs, where it provides a efficient power, so while it is having a multi-year battery life. So all these are the different examples we can see, remote sensors and also actuators. So these are the different connecting how the massive Internet of Things with our 5G. So coming to the new mission critical control services, as we said, we can use it in industrial, autonomous vehicle. So these are the just basic examples I am giving for how we can able to use our 5G for ultra reliable, low latency communication, robotics in medical field, and where it has having a high reliability in industrial automation, energy, smart grid, everything. We can particularly use this 5G. Then coming to particularly, as we have seen the examples on the applications and also how the 5G can be used, let us go what is actually with the difference between our normal LTE versus 5G. So as we say, LTE, long-term evaluation, and also with respect to 5G, we can use it in different cases where the mobile broadband access and it provides a latency of only 10 milliseconds, and the bandwidth is up below gigahertz in the LTE. Coming to 5G. Mobile brand mobile broadband or URLCC, ultra reliable low latency communication. These are the different cases we can see in the 5G compared to this one. And MMTC, massive mobile communications also it is possible. Next, specifically in our 5G, we can avoid on signals and only always on signal. The only one is the SS block, always on signals. So these are the differences what we see with this 5G versus LTE. Next, these are the different frequency antenna configurations. We can use the particularly 64 to 56, that is number of elements and scenarios of different frequencies. We can see at 700 megahertz, it is used for which extremely long distance, or for urban or rural or high speed. On the highways, what is the different antenna configurations we are able to provide. And with respect to that, the bandwidth starts from 20 megahertz to 1 gigahertz, and the different antenna configuration, 64 antenna configuration or 4 or 256. So whether it is used for the high speed or indoor. So these are the different frequencies and bandwidths and different antenna configurations which are applicable for 5G for different scenarios, where we can use it for extremely long distance, urban for MMTC. So all these dense urban, rural urban, all this come into picture. So dense urban or particularly for 5G network, the dense urban means an analysis of this enhanced mobile. In particularly, if you take the frequency as fixed to 1 gigahertz, so to cover urban, suburban or rural areas, we need a support of network. So that is possible through IoT services, where it is used for Internet of Things. So the frequency ranges for spectrum ranges and is applicable to all the commercial 5G networks. Next, coming to the operating frequencies, which can be applicable for this is this 2.2 frequency ranges. The first frequency range which can be applicable is from 410 to 7125 megahertz and the duplex mode. And as we know, TDD and FDD, time division plexing and FDD. So these are the two frequency ranges which are applicable. And these the FR1 is sometimes referred to as sub 6 gigahertz, and after this particularly frequency range is comes to FR2. Excuse me. So these low frequency bands are generally applicable where we are using this, and this FR2 as it is can be used of above 6 gigahertz or high frequency band, which are the extended bands of 5G. And also this can particularly FR1 band is applicable only in C2 C band, whereas FR2 is applicable for 5G bands. So the FR1 frequency is generally in particularly 410 to 712. So these sub-frequency, so the FR1 is nothing but called as frequency range 1, frequency range 2, where it has a sub 6 gigahertz frequency band, which covers a potential from 410 megahertz to 7125 megahertz. And coming to 5G NR frequency range 2, it has been allocated about 24 gigahertz to particularly this frequency range, which is in the applicable. So FR1 sometimes referred to as sub 6 gigahertz, and also coming to particularly why only TDD is opted for F2 range in the 5G, and particularly in this is it is has a high channel bandwidth. So this FDD uses separate frequencies for the uplink and the downlink, whereas TDD uses a single frequency for both uplink and downlink. That is the difference in these two duplex modes, which are the defined standard frequency ranges for our 5G communications. So these are the from wide area license spectrum. We have three types of spectrums which are available in our 5G communications: below 1 gigahertz, above 1 gigahertz, and as we said, above 6 gigahertz. Extreme bandwidths can be used, wider bandwidths, long range for massive Internet of Things. So this license spectrum will have a cleared spectrum. Shared license means, as we know, it's a licensing is a complementary and it's used on shared basis. Unlicensed means many multiple technologies are applicable. So we can this particularly this topologies like a DD2 and also mesh type of topologies are supported from these deployments. I hope everyone knows this device network topologies like mesh and DD2, device to device. Next, coming to the basics, if we go for them, building blocks for 5G are millimeter waves, small cells, massive MIMO. Next, coming to beamforming and full duplex. These are the basic building blocks we are using for this our 5G communications. So coming to this millimeter waves, these will have more devices and also particularly can be used for cramming of RF spectrum. So this cramming of RF spectrum where particularly more number of frequencies can be used, then this particularly adopts several different methods like frequency division multiplexing like OFDM can be used in cramming of RF spectrum. And also we can use at gigahertz bands, terahertz bands. And these, as in the diagram, you can see the frequency ranges where it is applicable 3 kilohertz to 6 gigahertz. We can use it for mobile, TV, and also above 300 gigahertz, how we are able to use for different applications, and also the RF spectrum puzzle. So these will have particularly the millimeter waves is the basic building block, whatever we have seen. And why wave is as it more devices consume more data, so causing slower services and also dropped connection. These waves are helpful in consuming more data. So as we know, it is a very millimeter waves are very small waves which possesses the frequency ranges of below 3 kilohertz. If the frequency range is above 3 kilohertz, we will have more devices which will consume more data, and all this will take place in the particular 5G. So these are the portable mini base stations where we can use it in our 5G communications. So coming to the small cells, in the second block of our 5G small cells. So these are used because it is having a efficient frequency reuse is possible through small cells. And in the rural areas, we can easily set up 5G networks and also requires sheer number of small cells to render the service. So this is what particularly our unique features. So a large amount of cells can be deployed in the case of 5G, and we can be able to perform all those connections and number of operations which are being large to emphasize particularly extremely in the 5G networks where we want to cover it in the rural areas. Next, the next feature what we see in the 5G is massive MIMO. So it supports hundreds of antenna arrays and also increases the capacity by 22 folds. So multiple input and also multiple output. So these are the different challenges faced while we use a massive MIMO. So next comes particularly the next building block. What we can see in our 5G is beamforming. So beamforming is the traffic signaling system for base stations. So it identifies which data delivery route to a particular user is efficient and it delivers the particular information. So there are many techniques can be implemented. The one which uses this beamforming is MO, massive MIMO, multiple input, multiple output, where it uses spatial multiplexing to transmit independent and separately encoded data signals. So why particularly beamforming is used with 5G signal is to overcome the obstacles like interferences, range limitations. We are using beamforming in the 5G. So as in the particularly in 5G, we have three type of beamformings. One is called as analog beamforming, digital beamforming, and hybrid beamforming. So these analog beamforming, as we know, it will steer the multiple signals emitted by the array, and it uses certain phase shifters to send the same signal from multiple antennas, but with different phases. Next is digital beamforming. In the digital beamforming, each antenna uses RF chain, and also it performs some methods like spatial multiplexing, where it will transmit a superposition of signals, and each signal will have its specific directivity. Next, coming to hybrid beamforming, this method will combine the both digital and analog, and it is carried out in chains, and it will have a number of antennas. So the particularly this solution can be used where you can use for waves in FR2 bands. This particular beamformings are applicable in our 5G, and it can be used with respect to FR2 bands as discussed in the previous slides. Next, coming to the next building block of particularly full duplex. So as we know, it is you can be able to transmit, or it can be able to receive the same frequency. It is able to send, that is called as full duplex. So on the same frequency, we are able to transmit or receive. So this completes the basic building blocks of our 5G. Next, coming to the next particular model of 5G. What we have to discuss is 5G channel model. So the 5G channel model, we can say particularly the radio channels are being deployed already currently, but we are optimizing it in communication networks to get the maximum performance out of them. So the antenna transmission we can provide is a narrow beamforming technique to improve network performance. And also extensive research is currently going on in the world to why this particular channel model. So the control key parameters which are designed for our channel model are channel delay spread, Doppler shift, and also MIMO correlation. So the channel delay spread, where a multi-path of mobile communication channel, it is a difference in line of sight between the existing time of the arrival and also latest multi-path component. There, this control key parameter, we can calculate at wave and also at the 3GP with different frequencies. So 500 megahertz is to the 100 gigahertz is the design frequency range to carry out the 5G channel model. So already we know in our radar systems, we observe this particularly Doppler shift. Okay, so Doppler shift, particularly change in the frequency is observed, is called as Doppler shift. An observer can move relatively to the wave source, and its causes are any kind of frequency or any moving source, an object traveling towards an observer, then we can observe this particular Doppler shift. Coming to the MIMO correlation, which is and another important control key parameter, is evaluated by using the correlation quotient. So it will particularly in wireless communications where we have a spatial correlation between a signal spatial direction and the average received signal. We are going to calculate this MIMO correlations, and it can be evaluated by using the correlation quotient. So all these are the different control key parameters for our 5G channel model. So in the delay profiles, we have two models: control delay line CDL, the full 3D model, and also tapped line delay, simplified for faster simulation. So you can see the base station and also particularly clusters and also to the paths, how the signal. So we have to take all these control key parameters, and we have to design this particular 5G models by using a control delay line, which gives us the full inspected full 3D model, and also which can the tap delay line TDI model for faster simulation. Excuse me. Yes, this is coming to the till now we have discussed only the theoretical part or the example part or the basic channel model. So coming to the next level, where we want to implement is by using a tools like simulations, or we want to perform. So this 5G link level simulation is important in our wireless communication. By using MATLAB, we can perform, or we can even use this link level simulations and for point-to-point communication links. And what does it evaluate? It evaluates some SNR, signal to noise ratio, interference ratios, if any error rates of bit error, or if any block error rates are there, this link level simulations are carried. So for that, we require a reference model, and this 5G link level simulation provides end-to-end physical layer reference model, verify its implementation, and different algorithms are carried out on the link performance. So coming to DLSH, downlink shared channel generation. Next, particularly it maps the physical downlink channel will be mapped, and the waveform generation OFDM or orthogonal frequency division multiplexing. Next, FODM. So in 5G, FODM will provide example for ortho multiplexing with the filtered OFDM. So this FODM will filter any errors in the particular signal, and also particularly this type of filter is used where any sort of spectral efficiency errors we achieve, or any multi-carrier modulations or any interferences are occur where the carriers will not be able to transmit the data. Then particularly this OFDM, FODM, and also WOFDM. So WFODM by windowed OFDM, where each particularly in the MATLAB, if you use this simulation tool like MATLAB, where you can use the windowing techniques in our tool processing toolboxes, and each particularly with respect to time domain, we are able to process each subbands and allocate the waveform generations. So these different simulation methods are applicable in the waveform generations. Next, coming to the channel models, which are a channel model, that is TDL, CDL, or particularly TDL. The channel model is how we send the signal through this channel model, and if you receive multiple signals in a lot of clusters, as we have seen. Okay, so each cluster, as we know that it is having multi-path components, but with some delay. But that slight variations of the departure and also arrival all should be traced by using this channel model. So it's a mathematical representation of where our wireless signals are propagated. Uh, and this TDL, the coming next channel is new tap delay model. It is on basically on indoor radio wave propagation, and wherever we want to measure this particularly, this channel model either CDL or TDL can be implemented in the 5G link. Next, so from synchronization, wave modulation will happen. Next, it goes to the link layer. Next, you can see the daughter lines where it has a HARQ, hybrid automatic request, which is used in wireless communications generally. And why it is used is if we want to have a particularly a reliable data source, then we are using this particular HARQ technique. So where the receiver will get a new data with some errors. That errors has to be corrected. If the errors are minor, okay, there is no problem. But if the errors are complex, then we have to send a request acknowledgement to the sender. After getting the particular data, so it will receive the new data. So the HARQ is Q is the conventional method upon the ARQ. That is, we can use that in the digital communication like error correction methods and also error detection methods. So in this error correction techniques, we can use a soft combining where we will receive this particular bad data with some errors and we will rectify those particular errors. So this is the 5G link level simulation which is taking place. And after this, we simulate it on a MATLAB and we achieve these particular results with a different RBVS. So how do we particularly calculate, take particularly the throughput and also the signal to noise ratios and measured in dB at the different CDL techniques and also the TDL techniques, we achieve it through different OFDM orthogonal frequency division multiplexing. So this is the RF power linearization, which is giving our 5G frequencies a greater RF transmitter frequencies. So these particular power amplifier linearizations will have non-linearity and memory effects. The solution is we can use particularly DPDs, linearization adapted through digital pre-distortion that can be used in our 5Gs in order to avoid these sort of any errors. And particularly the DPD challenges is to increase the upload and download systems. DPDs are important. So if you use particularly an DPD, the channel of increased signal bandwidth, whatever we use will have an efficiency. So in 5G technology world, generally we are using this power amplifiers to enhance particularly the greater bandwidths, which are requirements of the RF transmitter efficiency. So the frequency dependent behavior and also highly integrated RF. So these are the different challenges in our 5G. So modern 5G systems, while using DPD, will have some advantages like wide bandwidth, multi-band and multi-carrier. TDD technique can be used and also massive MIMO. So DPD is one of the main important block in our communication system as it increases the power efficiency by linearizing the PA. So without the DPD, we are unable to use the particular PA with large blocks and also we are unable to achieve the desired output power. So this particularly the system cost will increase because of DPD, but a cost effective solution is provided to the expected output. So this is how the characteristics are observed while we have a linear the output power versus input power with the DPD characteristic and also particularly the linearization which is carried out in the RF power amplifier. So these are the standards we use to building the connected car highway, just as an example for future release using particularly this serial T system toolbox for short range communication, and also we can use the IEEE 802.1.BP standard for then we can use it particular for wireless local area network system toolboxes. Next, these are the future 5G uses for the connect cellular long range, comfortable LTE, and particularly reduced maximum transmit powers, and also we can use it for peak data rates, and also it can be used for narrowband IoT, where the network radio technology is developed by 3GPP for cellular devices and services. Particularly, this narrowband IoT cost and power reduction techniques are used in 5G, and also it are initially applicable for 4G LTE standards. So there are no higher order modulation techniques which can be used for this 5G future case. Thank you, sir. Any queries you can ask me now.
Okay, ma'am. Thank you, ma'am. All the participants, if you have any questions, raise your hand or type in the chat box. If you have any doubts, can raise your hands or type in the chat box.